Hello, Calculus 1 students. In this video, I'm going to work two examples where we find a derivative or an instantaneous rate of change using the definition of derivative, and then we will find an equation of a tangent line. So the first example involves a 1 over something. This comes from Final Exam Fall 2022. The second example involves a square root, and this comes from Final Exam Spring 2017. There are strategies in each one of these types of problems that we will practice. Okay, so let's get started. Number 1, f of x is 1 over 9 minus 2x. We want to use this limit definition of the derivative to calculate the derivative at x equals 1. Well, first of all, start with the numerator, which is f of 1 plus h minus f of 1. We have 1 over. We'll evaluate at 1 plus h. So we put in 1 plus h, and for this x, we have 9 minus 2, quantity 1 plus h. This is an important first step. Now we subtract off f of 1. We can't see f of 1 is 1 over 9 minus 2, 1 over 7. I need to do a little bit of work on this first fraction. Altogether, you see I have 9 minus 2, which is 7, and then I have minus 2h. So 7 minus 2h, and then I'll leave this alone. My strategy on a question like this, get a common denominator. So over here, I'll multiply by 7 minus 2h divided by 7 minus 2h. And then for the first term, I will multiply by 7 over 7. My common denominator is this product. We have 7 times 7 minus 2h. Now my numerator, I have 7, and then I have minus this. So I will go ahead and distribute my negative sign, but if you want to do that in 2 steps, perfectly fine. So I have a minus 7, and then I have a plus 2h. Minus 7 plus 2h. Whoa, we are in wonderful shape. You notice my numerator is just 2h, and this is where we want to end. Because my strategy in all of these, when I work with the numerator part of the difference quotient, I want to make this h times something. And I have done so. We have 2h. Now, let me make this slightly smaller, and I'm ready to jump into my limit. Okay, next, f prime of 1 is a limit as h approaches 0. Well, this is my numerator. And then I just divide by h. So that is going to be down here. H over h is 1. So I have a limit. As h approaches 0, we just have 2 over 7 times 7 minus 2h. Okay, fantastic. This is now defined at h equals 0. We may evaluate. I get 2 over 7 times 7, 2 over 49. This is my answer. Now, before we move on, we discussed in class how important it was to organize your work, how important it was to use equal signs when you mean equals, and how important it is to not use equals, well, when it is not equal. So here, all of this is equal to f of 1 plus h minus f of 1. But I wouldn't put an equals here because I have done something different. We start a new line. Now I'm calculating a limit as h approaches 0, and I take this, divide by h. That's what this is. And here is the limit. So when you're showing your work for a question like this, make sure your work follows logically. Start with the numerator and simplify until we have h times something. And then divide by h, and we take a limit. Make sure you write limit h approaches 0. This is what we are calculating here. Finally, we have our limit here. 2/49 is the derivative evaluated at x equals 1. Okay. Next, well, we've calculated the slope of the tangent line in part A. The slope of the tangent line is the derivative evaluated at x equals 1. It's also the instantaneous rate of change of my function at x equals 1. And then a point, which is on my graph, and on my tangent line would be 1 comma f of 1. F of 1 is 1/7. So my final answer, y minus the y value equals the slope times x minus the x value. Perfectly fine to leave this in point slope form. So this finishes this first question. The next one, we see a square root. The strategy is different. We practiced this in class on our worksheet today with a different function, but in this video, I will work this one. F of x is the square root, 3x minus 2, instantaneous rate of change of f of x at x equals 2. Okay, so we start off with the numerator, f of 2 plus h minus f of 2. Just like in the last example, I want to work until I have this as h times something, but my strategy is different. So first we evaluate at 2 plus h. We have 3, 2 plus h minus 2. Then evaluate at 2. Well, here I have the square root of 6 minus 2. Oh, okay, it's the square root of 4. Okay, well, let's simplify both of these here. My first term, you see I have 6 minus 2, which is 4, and then I have plus 3h. So this is 4 plus 3h, then subtract off 2. My strategy here is different. My strategy is, well, we take this, and instead of having the minus, we put a plus. But we have to multiply by 1, so we multiply by this. This is this conjugate. This is going to help me get the h out from underneath the radical. Now my denominator is exactly what we see here, so I will copy and paste. But then my numerator, well, the firsts multiply to 4 plus 3h. The inner and the outer add to 0, and then the last is minus 4. So we are left with 3h over this denominator, which is h times something. Now, new line, f prime of 2. This will be a limit as h approaches 0. Okay, we take this and we divide by h. Well, let's see if I can just paste it. Okay, fantastic. We just have 3 over this denominator, and this is where we want to be. This is defined at h equals 0. So now I evaluate this limit. We have 3 divided by, well, the square root of 4 is 2. So we have 3 over 2 plus 2, 3 over 4. So this is the instantaneous rate of change of this function at x equals 2. Another way to say it is the derivative of f of x evaluated at x equals 2. Now, once again, you see I started off with the numerator. I use equal signs until I have the numerator as h times something. Then start a new line, okay? The derivative, we take a limit as h approaches 0. It will be this divided by h, which is here. This expression is defined at h equals 0, and so we just substitute h equals 0. Really, that's properties of limits. Okay, this is the kind of work I expect to see from you. Equal signs used appropriately. Limit h approaches 0 is written. Very nice. The second part of this tangent line, well, very similar to the last one. We've already calculated the slope of the tangent line. It's the derivative. which is 3/4, and then a point which is on my graph and on my tangent line. This will be 2, comma, f of 2. F of 2, oh, is also 2. Okay, 2 is on my tangent line. So I have y minus 2 is the slope times x minus 2. And this would be my final answer. All right, this is the end of this example. The purpose of this video was, number one, a little extra practice with these two different strategies when you see, say, a 1/, or 5/, something like this, or a square root. And then number two was, how do we show our work on these problems, which I'm really pressing on this week. And hopefully we can all get this on our quiz. Thank you so much, class.